What does battery recycling look like today, and what needs to change to make it more circular? Welcome to the Circular Future, showcasing stories of circularity that reshaped how businesses operate and how you can do it in your organization too. I'm your host, Stephanie McLarty, Head of Sustainability at Quantum Lifecycle Partners, your trusted partner in electronics circularity. Today, we dive into the important topic of battery recycling. Look around you. So much is battery enabled today in our homes and in our workplaces. So what happens when batteries reach the end of their current life? My guest today is Danielle Spalding, Senior Vice President of Communications and Government Affairs at Cirba Solutions. Danielle shares some really neat examples of the impact of battery recycling, also the critical minerals that may lie inside of them. We cover how policy can keep up with the rapidly evolving battery chemistries, and also what's needed for safety and education. Really what everyone should know. This is such an important topic. I hope you enjoy. We'll get started after this short message. Picture this. Your company just landed a major contract and needs to scale up fast. But what about all that sensitive data on your old equipment? That's exactly where Quantum Lifecycle shines, handling everything from secure data destruction to responsible recycling. Turn what could be a compliance nightmare into a seamless transition. Go to quantumlifecycle.com for more information. Welcome to the podcast, Danielle.
Oh my gosh, thank you. It is very exciting to be here. So appreciative of you being able to take the time to have us on.
Well, I am so appreciative of you taking the time today, Danielle. And we're talking all about battery recycling.
Yes.
But first, let's have a peek into your world. What would be 3 things that we should know about Cirba Solutions?
Oh my goodness. Okay. I love that you start with this question because, but it's such a big question too, right? 3 things I feel like it could be so many.
It could be, yeah.
I'm going to start, I think, first that what I think if any listener really needs to know is that, Cirba Solutions has really played a significant role in really the growth of this domestic battery recycling industry in North America. We started back in around 1991. So actually, this is our 35th anniversary here. So
wow. Congratulations.
Yeah. Thank you. And 35 years, we have really expanded and thoughtfully, I think, grown very much within the market because we see these amazing adaptations and changes in the battery chemistries that the market adopts. And we've been expanding not just our services, but also processing capacity of batteries to be recycled over these, 3+ decades now. And beyond the fact that we have, 6 really operational sites here, 1 in Michigan, 2 in Ohio, Arizona, South Carolina, and we're also in Trail, British Columbia. But our focus truly, I think, generally and at our core is to help increase the public awareness and demonstration that battery recycling can help happen domestically. And our mission is to empower electric future to accelerate human progress. And we know that the circular economy is very much something that not only is important, but it's embedded in truly what we do day to day.
Totally. I love that. Yeah, the circular economy is so critical that we get batteries embedded in the circular economy. I mean, they're powering our devices, our cars. There's so much in them. In your words, how does battery recycling specifically support a circular economy?
No, we've got, I think, one, as you said, this, they power everything. So from the headphones I'm using to talk to you, the laptop in front of me, I've got so many devices, wireless keyboards, cell phones, right? Plus the vehicle I got here today, the energy that has helped power the building, right, has battery backups. So it's incredible what batteries are integrated in today. And really, when we think about the circular economy, batteries right now, especially people recognize that there's these critical minerals inside. And what Cirba Solutions does is help recover those valuable materials such as lithium, cobalt, nickel, even copper, and aluminum. But those are the areas that we help process multiple battery chemistries. So, for example, what I mentioned on those critical minerals would be lithium ion type batteries. We also recycle alkaline batteries, lithium metal batteries, and by doing this, we're able to help supply a domestic supply chain with increased and diversified sourcing for critical minerals so that one reduces our reliance on virgin mining, right? It allows us to have shorter transportation of materials and then the inputs needed for new battery manufacturing. It strengthens the domestic supply chain and helps our energy transition for these new technologies. Plus, I have to always say, right, it's going to improve the national security. As we see that there is so many wonderful partnerships going on, but we also need to ensure that we have both the ability to have resiliency and independence while still having partnerships abroad. But we can collect the batteries that are here today and then process them and then basically make them into a new battery. Okay, so I don't want to ask what car you drive because I don't know if you want all the listeners to point you out. Okay, what car
I've talked about my cars
Stephanie?
on the podcast.
Oh,
before.
yeah. Okay. What do we drive, Stephanie?
So currently, I do have a 2017 gas-powered car, but we have but our prime car now is a Tesla Model Y. Our previous EV was a Tesla Model S from 2013 that had 300 and I think it was 25,000 kilometers on it when the air conditioning broke and it was going to cost us $8,000 to repair the AC when the actual car was worth $8,000. So we decided to trade in. But the interesting thing was that the battery was still fine. We still had 85% life on the battery.
Yes.
So yeah,
we're gonna use both, right? Your gas and your EV vehicle.
Yeah.
So from your lead acid battery that you drive in today, and people will often. I just got mine actually replaced a couple months ago.
You got it replaced.
A lead acid. I had to, right? Like lead acid batteries they don't go as long.
Oh,
but,
okay. Yeah.
But yes, my lead acid battery. Within my vehicle. And so your lead acid battery in your vehicle, or what we would call an auto, right, lead acid battery, is actually made up of anywhere from 80 to 90+% of an old lead acid battery. So even today's market in the lead acid battery specifically is a fantastic demonstration that lead acid batteries are actually recycled 99+%. We can't say exactly 100, but 99.9%. And it demonstrates that not only is there a capability, but there is the accessibility, right, for battery cycling to be possible. And your then EV battery from your Tesla had so much energy left that more than likely what happened is when it was brought back, if it wasn't put directly into recycling because it had so much amazing, wonderful energy, right, density left within the battery, it likely went into the reuse market or repurposing market. So it could have been remanufactured to create a new EV pack, or it could have been repurposed into energy storage batteries and then leveraged, right, for that capability, which would then extend its basically life cycle of its use. And batteries have this magical power, I think, to provide not just an initial life, but so many multiple uses after that initial. And we find more and more ways, I think, to leverage both the energy and the materials inside.
And just for curiosity, so Cirba does, for example, the recycling of the lead acid battery, and you do the EV batteries. Like, do you play in the whole supply chain?
I mean, I'm going to be honest. First, we love all batteries, guys. Send us all your batteries. All listeners, send us all the batteries. Well, so we actually process, as I mentioned a little earlier, we do lithium ion batteries. When I say processing, I mean we are taking the battery apart. It's getting shredded. You're getting materials extracted, and we can go through the whole process. And for lithium ion, you get this beautiful black mass output that has all that beautiful lithium and cobalt and nickel right with inside the battery. We also process alkaline batteries, which is the most common household battery still to date. Something you'll find in flashlights and the remote controls and all those other kind of things.
I'm nodding my head because this morning we lost power. So I'm like, yeah, flashlights.
Yeah, the flashlights.
I know all about that.
And for us, we always keep those. We have lithium ion rechargeables at home for when we lose power, right? And we put one by everyone nightside tables and the bathrooms and everything. But also we do lithium metal, which is often in like a coin or button cell format.
Okay.
That you'll see in things like hearing aids or other
like
uses.
Watches. Yeah.
Yes, watches, love that. And so we process those three. We handle all chemistries. So we would handle lead acid, but we're not a smelter. So a smelter is a type of process used for those types of batteries. But we also, because we've been doing this for over 3 decades, we do everything from collection, right? We work with municipalities, telecommunication teams, automotive OEMs, battery OEMs, and all the way through to environmental service teams. Plus, we then transport. So we're unique because we also have our own fleet of trucks, and we will work with third parties, but we have specialized drivers that do reverse logistics to help transport batteries, of course, safely, compliantly, across, transboundary movement, whether that's coast to coast in the US, Canada, et cetera. And from there, we will then basically sort the batteries if they're small format, because they usually come in a mixed form. If they're large format, like an EV that you might have, then we will likely disassemble it, and then it will go to one of our plants for processing to then extract that goodness from inside.
Cool. Okay, so we've talked about the lead acid batteries and the car batteries. Like, what else are you proud of that you've been able to do at Cirba?
I can't take credit for this because it was here before I started, but I think what the listeners could probably really learn about is the alkaline process. So alkaline batteries do not have any hazardous materials inside of them. And oftentimes we hear about lithium ion, they're hazardous material, we got to make sure they're handled properly, and all of that's correct. But an alkaline battery is actually something that has inside of it is like a zinc and manganese. And if you look at that, they are actually a micronutrient. So we process alkaline batteries here actually in Michigan, where I'm located today. And it goes through a hammer mill, it goes through magnetic separation and filter screens, and the steel goes back into steel mills, right? And then a part of the black mass of alkaline batteries is a zinc manganese concentrate. And what we do is we sell that concentrate they work with fertilizer groups, and we actually mix it with the fertilizer to increase the nutritional value for the soil to help crops that are more robust, like corn, soybeans, etc. And so batteries can actually help grow some of the foods that you're eating.
That is crazy.
And it's an amazing example of how industrial over to agricultural industries, right, can kind of bridge together in a circular economy. And while it's usually industrial to industrial, but again, batteries have this magic to say, we're going to keep giving back, right, even in new forms.
That is so amazing and actually supports agriculture. I would not have guessed that. Like, that is, in my mind, like 2 completely separate. But why does it have to be? And in this case, it really works.
Yeah.
Now, you've mentioned around the need for having supply chains, transportation that's safe. Can you tell a little bit about like the risks associated with batteries? What do you have to be aware of and careful?
Yeah. So I think that I'm going to start because a lot of the audience I know handles both small and large format type of batteries. So I'm kind of separate this, if I may, to 2 difference. One, I'm going to start with the small batteries, right? The things that basically you can carry within usually one hand, a power tool pack, AA batteries, right? This kind of thing. And small format batteries, one is there needs to be more education on battery chemistries. You know, when we think about, believe it or not, go back to high school in your science class and chemistry, and they're trying to teach you the periodic table, right? and and so what we need to know is first is that when we recycle batteries, one, it's possible. Okay, recycling
Okay.
happens today locally. You can do it. But the second is we want to properly prepare the batteries for recycling. And if it's a lithium ion, so if you look at the battery, it should say lithium, right, on it, or lithium ion, or Li-ion. And the goal for us is just tape the two ends of the battery. Now, I know our listeners can't see us, but I happen to have a small little battery here. Well, it's a stress battery.
It's okay.
Off. But it's the two ends of the terminals, basically the positive and negative sides. And if you just put a piece of clear tape, that's really all you need to do to help prepare for recycling. And we do that so we help minimize the potential of terminals hitting each other, or, you know, metal against metal, for a potential spark of some kind that can create what is considered to be a thermal event or fire when it's either stored or in transport. But the other part of this is that when you recycle your batteries, often for small format, it's usually just the dry cell. So things that basically you don't hear liquid moving around inside. And you have to have a special permit in the United States and for a DOT, and there's equivalencies in Canada as well to have those permits to have commingled material. Because I'm going to be honest, not people sit around going like, let me separate out my battery chemistries.
No.
Like, they just want to know it works, right, when they use
Yeah.
it. And then they know when it doesn't work, for sure. So when we get through with it, we can go ahead and put it into the collection unit. Now, if this is a large battery, like an electric vehicle, an energy storage, a UPS, so an uninterrupted power supply, with those specifically, you're going to have trained teams likely, not just remove them from where they might be, right, but also do the actual disassembly of those materials. And that's because, one, there's a clear increase of energy density within those, and safety is first and foremost paramount within our industry. But secondly is that we want to ensure that, again, even all of those parts of the batteries, the steel outside casing, that should go back to the steel mills, right? The wiring, the copper inside, that should go back into the industry for reuse. And I think it's important that people know that we don't just take the critical minerals. We try to take all of the battery and set it on for a second life of use.
That's so cool. As you're talking, it's reminding me of what I'm seeing in particular our Toronto recycling plant for electronics, that the key thing is to remove all the batteries so that the batteries or the battery embedded devices don't end up in the shredder, because then that causes a thermal event or fire.
Yes.
And that's our biggest risk, is so we have to separate out the batteries. So yeah, so it's definitely something that we have to be very mindful of. So I love what you're up to, and you're making such a big difference for the world and for the industry
that's so
specifically.
kind.
What have been some of your learnings out of these successes along the way?
Yeah. So I think that there's two things, and it's going to build a little bit honestly on just what you said about even when you take your batteries for, recycling, is that there needs to be a lot more education. There needs to be education about, not, again, that batteries can be recycled, but where do you go to recycle your batteries? Because the biggest challenge, after we've done a lot of studies within the marketplace, has said, even if I know batteries can be recycled, I don't know where always to take them. And it's not consistent, right, from city to city. And we have to help, I think, provide more education and resources for, just the general residents, period, to know that where they have to go. The second part is that they need to not be thrown away. I think when you said also, what are we seeing in the industry? It's that we need to ensure that people understand batteries not are just valuable to industrial and agricultural, right, industries, but we want to make sure that our teams are safe. So please do not put them in your curbside bins, right? Because when those machines come in, they take the trash, they're putting it in the back, and then it's getting crushed down. Then that has a potential to then crush, the battery, puncture it in some way, and then create a potential thermal event within truck itself, and then putting the risk around not just that truck, but the driver and the residents where it might be close to. Or it could have to then wait for it to go into an event at a municipality, or I should say a material recovery facility, excuse me. And so that's really important. But I will say the biggest thing is beyond just the fact that we need to prepare better for battery recycling, it's the education about battery technology evolution.
Mm.
And so we see lead acid go to nickel metal hydride. We saw nickel metal hydride go to, or even a NiCad, and then we see that go to lithium ion. But lithium ion isn't going to be the end all be all, right? For forever, we're going to keep seeing battery technologies evolve and expand. And one, that's really exciting for us because now we've got such a diversification of optionality, but also it's going to mean that the safety concerns, right, that people have around lithium ion, it might just be something different now for the next technology, right? We might need to package that differently. We might need to handle it differently. It might need to be processed differently. And so when I think about this, because the policy landscape that we see now that has really focused on, ensuring that we can have safe collection, we have expanded collection and expanded education, we want to ensure that those trends also account for the battery technology evolution that will happen. And we don't want to focus just on one technology, but we want these types of policies to be applicable to the future as well.
That makes so much sense. So I guess in a sense, create a framework that could address any type of battery. Speaking of policy, can you give us a quick rundown on what is the policy landscape currently for battery recycling? Is there one?
Yeah, there absolutely is. And it is, I'm going to say robust. And so I will say in Europe, there is something called the EU battery passport that often a lot of people reference. And it's a very expansive support, not just policy, but regulatory compliance that's going to be going into effect. In the United States, we have a lot of extended producer responsibility legislation that has been enacted in some states. And then it is also becoming very active in others. So, but in the United States, we tend to break this apart between small format, medium, and then, propulsion batteries specifically. And then in Canada, as you've, I think, already well highlighted, there's been a big focus on the small format, but also there's fantastic trials with vapes as well to get the batteries embedded in those out. There is a big focus on the propulsion batteries or electric vehicle batteries specifically to get those collected. And what we really know is that as we see the advancing batteries, specifically things such as EPR, focus on both material recovery and safety. And there's going to be both call outs for what would be considered a primary battery or a non-rechargeable, and then a rechargeable type batteries overall. And the goal there is obviously to really support this design for circularity. And we're trying to really bridge this policy and the real execution so we can have legislation turn into really measurable, impactful, right, pieces from not just state to state, but hopefully country to country.
Okay. That's so interesting. So we need to really look at the types of batteries and have solutions for both small format and large format. Is that right?
Mm-hmm.
So it's really in addressing the small and the large types sort of separately, although I would suppose like holistically as well.
Yes. Small format batteries are typically handled by local municipalities, environmental service companies, et cetera. But the large format network is very different. It's much more business to business than it is going to be, business to consumer necessarily, even though the consumer is the user, right, often of that large format battery in the sake of electric vehicles, but in energy storage, it's going to be a business, right? And construction equipment, it's going to be a business, right, et cetera, et cetera. And so what we need to do is when a consumer even then brings their vehicle back, like when you then went and changed out, right, for the next Tesla model that you guys received, it's done by the dealership or the automotive, right, team that's handling those batteries, whether it's an auto scrap that's then receiving that vehicle or the network really in that particular supply chain. So small format and large format really do need to have separate approaches because of not just the concerns specifically, but also they are just completely different networks and how they're handled. And there's packaging requirements and safety issues and transportation concerns, right, against all of those. I hope that one day we can get to consistency. And I think the EU has done a really nice job in helping to implement that consistency with the battery passport that they have. The states are really aiming very much to try to have some more consistency, very much like what Canada is also doing. But there are going to be uniquenesses between state to state because each region has their own concerns, right, based on what their residents are coming back to those then stakeholders with feedback on. And when we think about, I always like to talk about the damaged or defective material that is often referenced, but it's not a big part always of the conversation. It's an important part, but we're always just focused on the main standard recycling. But when a municipality gets a damaged battery from a resident, for example, they need to have something ready and available to go right then and there. We don't want that material to sit for a week, right, without being properly packaged. Because again, the safety side of many of things. So the more consistency we can have, definitely the better. But our goal overall, when we do look at this, is make sure that education and outreach is embedded right into what that policy landscape looks like. Ensure that we allow for the existing, supply chains that such as Cirba Solutions, right? We already exist. We've already got extensive hundreds of location sites for collection. So we want to make sure we can keep working with those. And we will always, no matter what, advocate for design for recycling, and that's through a multitude of partnerships, whether that's with large or small format. And we know it's hard, and the embedded batteries is such a unique market to talk about. But our goal really is just to help make battery recycling not just accessible, but hopefully a standard behavior.
Hear, hear, you are speaking my language. I mean, it's all the things that we at Quantum preach about electronics, and of course, in a lot of electronics, there's a battery or a plug. So I am with you on all that. And I can't believe it, but the time has flown by.
Oh my gosh! I'm so sorry. We just kept talking there.
No, this is what happens when it's a really interesting topic with a really interesting speaker. So one last question, but I wanted to ask it in two parts, and we always end the podcast with final piece of advice. So first of all, what would your final piece of advice be for the average consumer? Like when they have all these batteries sitting at home, what should they do with it? Where should they go? Like, should we go to your website, for example?
First off, yes. CirbaSolutions.com. CIRBA solutions with an S.com. No, of course, please go to our website, check it out. We've actually got wonderful information on even about batteries, how the use of batteries and different types of materials, as well as, information about damaged lithium batteries. We try to make it very educational for whether it's a general resident or a business. But I would say just as an average person, please collect your batteries, and they should be accepted at a local household hazardous waste collection day. And, when you bring your paint and you bring your other things that you're trying to get out of the garage, think about the junk drawer, think about the things in the garage that, that power tool pack that needs to go, or when you go downstairs and you've got all those beautiful electronics that were really high tech 5-10 years ago, right? And now they've kind of been replaced with a newer version. Bring everything into that household hazardous waste day, please, because then we can make sure that everything goes in the proper avenues, ensure that we can work with great partners like Quantum, and then ensure that we get these materials back into the supply chains that we have.
Okay, awesome. And, at least around here, there's lots of those hazardous waste days with spring. And because
yes,
coming around the corner. Things out. Yeah. And I know with where I live, there's an ongoing hazardous waste drop off that we can bring them to at any time of year through the local municipality. So, okay, great advice. Second part of this last question. What's your final piece of advice, say, for the industry at a whole?
Since you gave it to me in two parts, can I take this one in two parts? Would that be okay?
Absolutely.
Okay, great. I think the first is that as an industry, battery recycling is not just an option, but it is something where we've got a strong market growth and a vision to help not just enable, right, to have materials support a domestic supply chain, but it allows us within North America to hopefully process critical minerals and eventually, right, be a exporter of critical minerals. And so if you don't have a program today, just start simple, right? Go onto our website, get a kit. It comes with everything you could possibly need. But if you do have a program, think about small expansions. Are you letting your employees, right, bring their batteries in? Are you ensuring that it's collecting the holistic batteries within your facility? And when I say this, I mean, there are batteries from, not just the everyday tools that the office and professional staff use, but all of our operational teams. They have a huge amount of in all the scanners they do, right, to connect to their software systems, to the forklift batteries, to, you name it. It's if it lights up, makes a noise, right, and it doesn't have to plug into the wall, it's likely got a battery in it, guys. So please make sure what we can do to expand. And then I think the second part of that is, if you've got questions about a program, about if a battery can be recycled, reach out, right? We want to be a resource for the industry. We're here to be a partner, and we're here to help people guide themselves through as they keep expanding, or even exploring, even with a toe into the water, into the battery recycling industry.
I think that's such an important message. If you have questions, which I think a lot of people do in the industry, reach out. Like, we're in this together. Let's partner. And I think that the message I've heard today too is just the need for consistency, allowing for uniqueness, though, the different formats, and education. It often comes back to education. We need to educate on the importance of battery recycling, electronics recycling, all of it, like doing the right thing for the planet and how to do it. Thank you so much, Danielle. You are amazing.
Thank you.
And I appreciate you being on
so fast.
And remember, if you're looking for a partner to help you manage the life cycle of electronics, we'd love to chat. Head on over to quantumlifecycle.com and contact us. This is a Quantum Lifecycle podcast, and the producer is Sanjay Trivedi. Thank you for being a circular future champion in your company and beyond. Logging off.